I can start with saying my background. I started at Snell Wilcox as a broadcast equipment manufacturer a long time ago, and did then a whole bunch of work in startups in London before joining Meta a long time ago. Anyway, I want to talk a little bit about the next generation of open audio coding and rendering standards. Really, this will be informative talk. There will be very little technical detail for this. I'm an engineering manager at Meta, which means that I help support the talented engineers that we see and we've heard from on a day-to-day basis. But in my spare time, I support AOM as one of our standards chairs. Background, I talked a little bit about, but I would like to say Media Foundations, which is the group that many of us are from, is responsible for the platform that you see that does creating, sharing, and consumption of content on all of Meta's apps. So it gives us the scope. So maybe all of you have heard about AOM. It's the standards body that came behind AV1, which is the best-in-class video codec standard. And it was actually founded not just for video, but also for all visual media and audio as well. Founded in 2015 on that side and has been going since then. Who are the members? Members are the great and the good, as well as many others in this space of technology for video, audio, and many other places in media. So I'm going to go back a little bit and say, I'm going to cover two different working groups very briefly. AOM is a big organization and has many different groups. The two groups I'm going to cover, one is the Storage and Transport Format Working Group, another acronym for you, AOM STFWG. Right? Remember that one, because we're also going to talk about AOM ACWG as well later, but we'll get there later. The Storage and Transport Format Working Group manages how do we package the media? How do we make sure that AV1 and other codecs can actually be managed and distributed widely? And here, last year, they distributed the first version of the Immersive Audio Media Format, IAMF. This was published last year, and actually has been now brought to market by Samsung and Google under the brand name Eclipsa. It's a way to distribute channel-based and ambisonic immersive audio between platforms like YouTube and devices like TVs. They're now working towards V2 of this, and the reason this is important is because they're starting to bring in object-based audio content. And to make object-based audio content available, you actually need a renderer. You need to be able to turn it into either binaural or loudspeaker-based reproduction. And there wasn't a standard for this available. And so they came and talked to me, yay, and said, can you build a standard for rendering? And we foolishly said yes. So let me introduce the Audio Codec Working Group, which I'm the chair of. I volunteered foolishly a long time ago. We develop audio codecs, pre- and post-processing technologies, and audio rendering technologies for open standards. And we do this with the cohort of companies that you saw at the beginning to make sure that we can continue to distribute content at scale without licensing fees and other problems that come with closed and proprietary codecs. We're really focused on full bandwidth scenarios. Speech is very well covered elsewhere, and we really are interested in not just the speech side, but also music and other content. Our primary goal is to drive down the bitrate consumption of audio. People ask, why is this a problem? It is a problem. Audio is a reasonably large percentage of our egress, and enough that we want to invest in this. We also want to bring this kind of bitrate reduction, not just to classic stereo and mono content, but also spatial content, which we haven't seen up to now. We're very much focused on VR, AR, and mixed reality experiences, and providing standards that we can be used in conjunction with IMF, as I just talked about earlier. Okay, why do we need another codec? There are many codecs out in the world, and I'll have a slide about them in a second. I want to start with the context that 3.3 billion, I think it's now more, I think someone mentioned 3.4 earlier. The number keeps going up. Video now represents more than 60% of watch time spent on our apps. It's a huge amount of time. And we see that double-digit percentage growth year on year on Instagram, as well as other surfaces. This means that it's continuing to consume more and more bandwidth. So we do need to invest in better codecs, better compression technologies. We also found in our work for wearables like glasses and other tools like Quest that there's a huge amount of room for improvement in the capabilities of modern audio codecs when it comes to spatial content. So what does the codec landscape look like? This is probably the most colorful slide so far, I'm afraid. We have Opus sits across that full band, but we also have a number of other codecs that live across different sections of the bitrate quality curve. We see novel codecs like MLO, Satin, and Lyra, where we think there are technology pieces that we can bring in, as well as other object-based codecs that are interesting in this space. What are our requirements? When we're thinking about codecs, why do we care? Where is our focus? It's VOD, live, and calling, RTC. We want to chase egress and storage savings. We want to bring spatial audio support. And we want to make sure, most importantly, that these tools are available for everybody. One of the key pieces that is interesting about our work is because we're working both on the video and the audio domain, we really care about the interaction between them. And one of the things we found is that traditional audio codecs don't interact well when being processed alongside video. Things like chunked-based processing, something that's important when we have heavy processes. Things like aligning audio and video frame sampling means that splicing multimedia content is very hard when you include audio. And including explicit metadata to enable you to understand the content without having to decode it is really important. So I'm going to move on. So that was audio coding. The other class of our work is audio rendering. Oops, sorry. Is that right? Yeah, there we go. A very short slide because it's relatively new. I talked about this a moment ago. IMF wants a renderer. We're going to build out standards for binaural rendering and loudspeaker rendering. You'll have seen the recent work from Google that got open source. They have a new open source binaural renderer, but also we're working on the loudspeaker side with Samsung. So both of these technologies will come into an open standard form in the coming months. How far along are we in this journey? And I'm almost done. Requirements are complete, agreed, signed off, both codec and renderer. We're in the middle of writing code. We're in the coding phase of this piece. And standards writing will come shortly. Last slide. Codec level design. Yeah, I forgot to mention, I'm sorry. One of the things that's really interesting is traditionally you have this render at the end. One of the things we really want to explore is, because we start to standardize the renderer, can we start to make optimizations at the encoder and decoder? Because we can tightly couple the decoder and the renderer. Some interesting savings, potential savings there. The other side that we're exploring at the moment is how to deal with the spatial pre-processing to enable better bandwidth savings at the encoder. Anyway, and oh yes, I forgot about this slide. I'm sorry. For those of you who are interested, we're basing the audio codec on Opus. This is a widely available one. We work with the Opus team there. We still see, even though Opus is really, really good, we still see traditional gains that can be made, but also areas where we can bring in ML-based tools to make a huge difference to the available bandwidth that we require, especially in the speech side. This is the point of my talk. If you're interested in audio coding and setting the future, please come and join us. Yes? AOM, open org. You can either join as a company. If your company's already a member, make sure that they signed the audio codec charter. And if you're interested in joining us, please do. If you're interested in this problem, Meta's hiring. I'm sure others will say this again. You can come and join us. I think I'm the only Meta person to say, please come and join us. It's because I'm an EM. I need more people in my team. I'm sorry, I'm only joking. That's everything I wanted to say. I want to say thank you very much for your time, and I will hand it on to the next speaker. Thank you, guys.